Okay, so we're on our final part of this module, or I mean, these are broken apart. I don't really know which way you guys are watching them, but this is the final part in the module. So, we are on to Bronsted. If I could find my thing. Again, I hate when I do that. But okay. We're on to Bronsted Acids and bases. Which essentially they're just ways to identify acids and bases in equations. That's not bad. But okay, so a Bronsted acid is essentially your proton or H plus donor, as in it gets rid of a hydrogen ion every time in the reaction. So that means that your Bronsted acid not acid, that's what we just did, that your Bronsted base is a proton acceptor. So that just means that in this case, this one accepts your H pluses, and I just realized that I've been misspelling Bronsted every time. It doesn't have an A. Ignore that. That's not there. It's just Bronsted. But okay, that's not as important. But something to keep in mind with Bronsted acids and bases is that you have these things known as a conjugate base pairs, where essentially every acid has a conjugate base and every base has a conjugate acid. So then I guess the best way to do this is kind of to just throw ourselves into the fire and do an example. So take, for instance, if we were to do chloric acid, which is HClO3 plus H2O yields ClO3 minus plus H3O plus, which this H3O plus is known as the hydronium ion, but that's not that important right now. But just so you guys know. So this is literally called chloric acid. Yeah, hydrochloric is HCl. My bad. But yeah. So this is chloric acid, so we know that this is our acid. So then this has to be our base, right? So then if this is our acid, then that means that this is going to be our conjugate, which I'm just going to write a C here. Our conjugate base, and then this has to be our conjugate acid. So it's these two go together, and these two go together, right? And you guys can clearly see here that the HClO3 lost its H, so therefore this is your acid, and then your H2O gained an H, so that's our base, right? And then if we were looking at this reaction backwards, the H3O plus ClO3 minus would give us the H2O, so we see that our H3O lost an H, so it's our conjugate acid, and then we see that our ClO3 gained an H, so that would be our conjugate base. So then let's do another example with ammonia plus water yields NH4 plus OH minus. So then, okay, Water's funky because water can be both an acid or a base. It just depends on what it's reacting with. So then take for instance this one. I mean, yeah, if we just didn't know what's happening, we look at our products and we can see that the NH3 turned into NH4, which means that it accepted the H plus, right? So that means that it's our proton acceptor. So this is going to be our base. So let me do that in a different color because I forgot to do that last time. So this is our base and this is our conjugate acid. So then looking at the water, we can see that it lost an H. So since it's losing the H, it becomes our proton donor. So then this is our acid and this is our conjugate base. These go together and these go together. So yeah, like I said, if you don't know if your water is either an acid or a base, just look at what you end up with. Because if you have an OH, that's obviously going to be a base, right? OH is basic, so that means that your water to begin with was acidic. Whereas if you have your H3O plus, then that means that your water to begin with was a base because you were gaining an ion. And same with the other things. Just if you don't know what's what, just look at the movement of your H pluses and where they end up, and you can just work backwards from that. So yeah, that's it for this module. There's also a PowerPoint that you guys can look at that has some extra problems in it, just in case, and more, well, not more explanation, but like a written explanation if you want to look at it. And if you have any questions,